everyone, and welcome to our lesson on writing equations to describe functions. When we need to write an equation, we may be given a chart of values or a table or just a list, and we need to form a slope-intercept equation from that information. So we're going to go through the process of doing that and describing that function with our slope-intercept form. So let's look at a real-world example. Let's say that we are given a table of values of coordinate pairs that represent something such as hours of time studied by a student and the grades that that student made on each test. So if we look at this chart and we interpret this information, this would mean that this student studied 2 hours and scored a 50. And they took a different test, studied an additional hour, 3 hours, scored a little bit better, made a 60. And you can read the rest. And took the test at the end of the week, studied 6 hours, and did really well and scored a 90. So they had a pattern of more hours studied equaled more points on their test or quiz. So suppose this was our table of values that we were needing to write a function for. What we would need to do this is we would need two things. We need a slope and a y-intercept. Because slope-intercept form is y equals mx plus b, where the m is our slope and the b is our y-intercept. So we're going to have to use our slope formula to find the slope, and then we're going to take that number and one of our coordinates and plug all of the information in to solve for our b. That's going to be our strategy. Okay, so you could really take any 2 points from that table, but I chose the first and the last point. So 2 hours in relation to the score of 50 and 6 hours in relation to the score of 90. All right, to find slope, we have to take our difference in y values divided by our difference in our x values. So I've taken the y values up top here, 90 minus 50, and divided by the x value difference, 6 minus 2, came up with a slope of 10. So remember, that is going to be our m that we're going to substitute into our slope-intercept form. We found our slope is 10, and now we can choose any coordinate from the table and plug in that x and y to slope-intercept form to find our b, because that's the last piece of information that we're missing. So I chose the first point here. So we've got an x value and a y value and our m value. So we're just going to start plugging those in. Y is 50. So he will go first. Equals m is 10. Our x value is 2. And we don't know b. We're going to solve for that. All right, so 50 equals, we can do this multiplication here. 10 times 2 gives us 20 plus b. And to solve for b, we're going to need to get that b by itself. So I'm going to want to get rid of this 20. It's a positive 20, so we're going to subtract it from both sides. And we have just found that our b, our y-intercept, is 30. So let's put this all into slope-intercept form. We've got m is 10, b is 30. So up here at the top, y equals 10x plus 30 will be our slope-intercept form that represents this chart of values. So why would this be helpful for us? We can use things like this to make predictions about the future. If we can find an equation that represents our chart of values, then we can find a pattern of sorts, and we can predict anything about the future that we want to. For instance, let's say we wanted to know if this student continues in this pattern and continues to score better the more hours that they study, what kind of score would we expect to see for a student who studies 7 hours? Well, to figure this out, we now have an equation to use. So we could just simply put that value in for x and see what comes out for y. So if a student studies 7 hours, we could put that in here and have 10 times 7, which gives us 70. Add another 30, and we have 100. So that's pretty good. We could score 100 studying 7 hours according to our pattern. What about a student who studies no hours? We could test that as well. We could put in a 0 for x, which would give us 10 times nothing, which is 0. Add 30 and we've got 30. So that would give us a score of 30 according to our pattern of values. So is this accurate? Not necessarily. I mean, they may not make that much better or worse depending on how much they study, or you could have an off night and different variables come into play. But these kinds of things are useful for finding a general pattern. So it's helpful if we can make an equation from our values so that we can use it for future values to test. Here's the math behind the testing of the 0 hours and the 7 hours. And this concludes our lesson on writing equations to describe solutions.